All right, welcome to 2.2, more of Transformers and more than meets the Y's. So the first thing that we're going to do is write an equation for each of the problems below. You'll build on the notes that you did yesterday a little bit, where those notes kind of told you what each thing did. So now we're going to go the other direction. And I'll do these first two with you, and then I want you to be able to do the other ones on your own. So the first one is the area of a square with side length x, where the side length is decreased by 3, the area is multiplied by 2, and then 4 square units are added to the area. So let's look through this. I like drawing pictures. I'm a visual person, so I'm going to think about a square where each side length is decreased by 3. Okay, so x minus 3. So I'm going to look at anything else that needs to happen before I multiply that together to find the area. And this is, the second part of this is the area is multiplied by 2 and then 4 square units are added. So I first have to find the area of this square and then I can do those other two things. So I know the area of that square to be x minus 3 times x minus 3, which when we multiply something by itself is just that thing squared. So I'm going to put a y out here as well. So I have y equals x minus 3 quantity squared. And now it says that area is multiplied by 2. So I'm going to take this whole area and just multiply it by 2 by adding that 2 coefficient there. Okay? And finally it says 4 square units are added. So I'm going to add 4. And there we have it. All right, so now let's look at number 2. We have to figure out what this equation is, right? So first thing I need to look at is where's my vertex? Well, my vertex is over here at 3 comma negative 1, right? So now I need to think, well, how do I put that in an equation? Well, when we were looking at the general term here above, we had all of these components in separate questions, right? We had this minus h, and what does the minus h do? Well, it moves it left or right, h, right? We have this plus k. Well, what does plus k do? Well, it moves it up or down by a factor of k. And then we had a, and what does a do? Well, it makes it either get steeper or squattier, right? Let's just say squatty. There we go. So this one, typically an x squared would be from the origin over 1 up 1 over 2 up 1, 2, 3, 4, right? That's what our typical x squared graph is from the origin. But in this case, what we observe is that we actually go over 1 and then up 1, 2 instead of over 1 up 1. So it looks like I'm actually having a factor multiplied by 2. And then I'm going to check that. I go over 1, 2, and go up 1, 2, 3, 4, 5, 6, 7, 8 is the next time that I hit one of those corners, right? So this is, in fact, a multiplier of 2. So that means that I'm getting steeper by a factor of 2. So I know that that A is going to be 2, okay? Now I just need to fill in the h and k, right? So h moves us left to right, and remember that's the tricky one. If it's negative, we move to the right. For a negative h, a positive h moves to the left. Okay, so I'm moving to the right, so I'm going to have a negative h. Well, how many? 1, 2, 3 is my right movement. So I'll say minus 3 quantity squared. And then finally, my k moves me vertically, either up or down. In this case, I see, let me change colors here just for clarity. I see that I went down 1, right, from this horizontal x-axis. So I'm going to say minus 1, okay? So that's kind of how we look at these functions, these parabolas, and we write the equation, all right? So I want you to pause for a moment and go ahead and work on these next two. If you're having trouble seeing that from the table, maybe choose to graph that using those values and see what happens there. All right, go for it. Okay, now that you're done with those, you will have the opportunity now to graph each of these three equations, 5, 6, and 7, without using any of your technology, okay? You can use a calculator if you need to, but really at this point we should kind of have the pattern of what these things do, what the negative does, what this plus 3 when it's out here in the K position does, what the plus 2 in the H position does. So go ahead and graph those three, and then we'll move on. Okay, now that you've got those three graphed, here's what we can look at. What point is the vertex of the parabola? Now remember, the vertex is just this point right here, regardless of whether the vertex faces up, or the parabola faces up or down, or it's super squatty, or very steep. Okay, the vertex is always that point where we change directions. So if we're looking at in terms of this general function here, what's the vertex of the parabola? Well, we know that h is our left and right move, right? And x is k is our up and down move. So if we're looking for the vertex of the parabola, we're going to take h, positive h, and k. All right? So it's our x-axis move and our y-axis move, okay? Now, when we're thinking about the line of symmetry is where we could draw the line to have this thing reflect about and onto itself. So if I'm looking at this, when I draw that line, that vertical line, any point that's over here could reflect and land right back on the function over there. Okay, same with right here. So the line of symmetry is directly in the middle. It actually is what intersects the x value of our parabola, okay? So our line of symmetry is going to be x equals whatever our x value is. It's going to be x equals h. So that's just a vertical line that no matter what y is, x is just always going to be whatever the h move is. So now, how can we tell if the parabola opens up or down? Well, hopefully you've discovered at this point a is the multiplier, but it also affects whether it opens up or down. So if the a is positive, it opens up. If a is negative, it opens down. Okay? And then how do we identify the dilation? So that's the multiplier again, and this is actually going to be also a. If a is 3, it'll be a multiplier of 3. If a is 1/4, it'll be a multiplier of 1/4, and it gets squattier, okay? So now, does it matter in which the order the transformations are done? So I want you to go ahead and think about that for a second. Think in terms of PEMDAS and things of that nature. And then we'll come back. So pause it for a second, talk with people at your table, and then we'll discuss it together. All right, so what we can find out is that it does matter because if you, let's say you do the dilation before you find the vertex of the parabola, you might have a whole bunch of different points now that you have to move to the right 3 and down 2 or something like that. So you might still get the same values if you do one before the other, but eventually it's going to be more difficult because you might have to plot the same points in one location and then move all of those points to another location. All right, there you go. Go ahead and work on 2.2, and we will talk on Tuesday. See you then.